all basically template problems, but I would recommend you listen carefully to this analysis. I'm not going to give you another hint. Can you all see that in the back? All right. All right. Is that the correct one, everybody? All right, now I want to go through this, but I'm going to do it methodically. The actual order that you do this is really not important. Brand new marker, too. Okay, so for this one, the switch is initially open. In other words, no current can flow down here. For t less than 0, you can ignore that switch entirely. Does everybody follow me on that? I'll redrop briefly over here. We're going to analyze this one. So for t less than 0, what you have is 12 volts. Then you have 3K. Then you have 6K. Then you have 3K over here. And here's what I'm going to suggest. For t less than 0, basically from t equals 0 to when time began, that thing has been in a constant state. There is no time variation. Does everybody follow me on that? In other words, there is no current through the capacitor, or it looks like an open circuit. Does everybody understand? Show of hands if you understand that. All right, so I'm going to just put it as two dangling points. We're going to measure the voltage across. We'll call that VC, t less than 0. It doesn't matter how you label that. Now, it's very important to realize that voltage here is the same as this voltage here. Does everybody see that? Class? Okay. Now, how do you get that voltage? Well, this is up to you. You all see all these resistors, the remaining resistors are in series. So if you want to, you could divide the voltage by that value to get the current, and then take that current and multiply it by 3K to get the voltage. How many understand that? I prefer voltage division. It's a little quicker, but you don't have to do that. Essentially, they're the same thing. I'm going to combine these two. And let me state again, I didn't say this at the beginning. We don't care about I0. Not now. We care about only the voltage across the capacitor. That's the only thing you want. Everything else you get from that voltage. Do you all follow me? So forget about anything else they ask. I'll combine these and say this is really 9K. Does everybody give me that? Far back, you guys see it back there? Just to make sure. All right, that means the voltage, and that's usually the first thing I tell people to find. VC across the capacitor, t less than 0. Well, that would be 12 volts. Then it's times the resistance you want the voltage across, which is 3K, over the sum of 3K plus 9K. Do you all agree with that? Or 12K? So that's 3 volts. You all give me that? Show of hands if you understand. The next step I recommend is throw the switch and draw the circuit. So when the switch is thrown, or when it transitions, I'm going to draw that circuit. Are you with me? So that circuit looks like this. Here we are for t greater than 0. And now, does everybody see when this shorts out? Effectively, it isolates everything over here from everything over here. How many see that? This, effectively, you can just erase that and take that right to ground. How many see that? All right? Maybe this might even help a little more. I think drawing it sometimes helps people. How many see that is the same thing? Can you all see it right now? Over here in the far back? You got it. How many do? All right, got to make sure on this one. This is critical. Remember, the electrical connections are the important part, not the orientation. I can take that resistor, stretch the wire, doesn't matter what angle it's at. Do you all follow me? Now, at that point, let me just get rid of this entirely. Are there any voltage or current sources in that circuit? How many see there are none? Can you guys see it right there? I mean, if you see there are none, what must the voltage across the capacitor be if it can discharge? Anyone? How many see it's 0? At t equal infinity, it's 0, right? As t goes to infinity, it's 0. That's usually the second thing I get. So VC t goes to infinity is 0. We good? Who asked me this one? You with me on that? Third thing is R Thevenin. Hear me. This people make mess ups on. This is one of the things, they have some problem with this, so I'm going to make sure you see it. So the third thing we need is R Thevenin. And why I'm at it, since it directly falls after this, you need tau, which is R Thevenin times C. We'll get both of these the next step. You with me? So here's how you get R Thevenin. It is the Thevenin equivalent resistance sensed by that capacitor. What I recommend you do is remove the capacitor. If you're having problems, some people will see it, you don't need to do it. Just remove it. Now, what is the equivalent resistance between those terminals? If you're wondering if they're parallel or series, and this is actually a legitimate concern, especially if you're a little nervous about this, you don't feel confident. Colored pens are your favorite, or pencils. What's between the black and the blue? Two resistors. They are in parallel. How many see they're in parallel? What's the value? I don't care how you get it, 6 times 3 over 6 plus 3K, or 1 over 1 over 6 plus 1 over 3, 2K. How many see that? And use your calculators if you get clumsy or nervous. Don't make dumb mistakes. My one caution for everybody is don't be overconfident. Go through the math. Slowly, get the right answer. Got it? Bookkeeping is essential in engineering. So R Thevenin is 2K. Now, what is R Thevenin times C? I think C was 200 microfarads. That's 200 times 10 to the minus 6, or 2 times 10 to the minus 4. You all follow? I'm not trying to be in any way insulting about this. People at times forget what that mu means or what K means. So if I have 2 times 10 to the minus 4 times, 2 times 10 to the minus 4 times 2K, I have 4 times 10 to the minus 1 or 0.4. You all follow. I don't care how you get that answer, just know it. So that's 0.4 seconds of the units. Do you agree with that? Now, you ask me, do you understand this? You ask me this. I hope I'm answering every part of the question you have. Finally, you put the whole thing together. You say VC of t is K1 plus K2 e to the minus t over tau. That's the general form. Just write it down. The first thing you do, in my opinion, is replace K1 by what, class? What's the voltage at infinity? It's 0. Do you agree with that? What's the next thing? I don't care how you do this part. Anybody, in your own words. Anybody want to talk? Or? You know what? You're going to evaluate this at the transitional point from 0 minus to 0 plus. Do you all follow me? What is that value? Put 3 over here. That happens at t equals 0 plus, right? If you're not seeing it, just watch. K2 e to the 0 minus 0. What is e to the 0, people? 1. So you erase it. Now I've got it. K2 is 3. I'm going to go right here. I'm not even going to bother putting in tau because that's over there, 0.4. You all follow me? Put it in the equations for the answers on the quiz. They're different on all of them. Make sure you put that value, box it, so each quiz you know what it is, and then insert it in the proper position when you write the equation and the time domain. Y'all hear me on that? Don't leave it as tau. Well, I knew what tau was. Make sure you state it explicitly. Finally, the last thing is, find out what they want. Now, this is the equivalent circuit, and this is the capacitor voltage. You all agree with that? They want the current through that 3K in the direction shown. How would you get it? How many C? It's VC of T divided by the value of the resistance. Sir, do you see? Did I answer your question? Did you have another part of this that I didn't see?
I understand it, but basically the question was when you flip the switch, I don't understand how you can just ignore the voltage.
All right, let me ask you this. Over here, I'm going to try to answer this for you. Let me see here. We had 3K, right? And then is the switch right here? Is that right? All right. Actually, that's a good, legitimate question. So at t equals 0 closes. Do you agree with that? Now listen carefully. I want to make sure you see this. When that switch closes, do you agree I can just replace that by a wire? Yeah. Now let's do that. You agree with that? Keep watching. Now, electrically speaking, is there any difference between what's drawn there and if I take this resistor and bend it straight down and put it like this? Excuse me. Like that. Here, let me go. I'm not even doing it right. I think, wait a second. That 6K is up here. I'm trying to reconfigure this too quickly. The 6K was up here, wasn't it, class? All right, and this is the 3K, my bad. So the switch, I'm just going to configure it like that. Now, electrically speaking, I can take, this point is the same thing as this point. So why not do this? See it now? In other words, this is grounded here, right? This is grounded here. These two circuits are isolated. Here's how you know. In order for current to flow, there has to be a path that doesn't have zero resistance between 2 points in the circuit. There's really only one point you can flow in at, can't flow out. They're isolated, electrically isolated when that switch throws. How many see that? Now you can play with this any way you want. Do you guys see it back there? I want to make sure. If there is somebody with uncertainty about this, ask the question. It's important, but that's electrically what happens. And remember this. You can have those resistors in any way you want, as long as the electrical connections are the same as they was before. It's the same circuit. Follow me, class? Did you have a question? I'm just asking because sometimes I'm not sure if you do or not, but if you're suspicious, please ask. Now you had a question. Where are you? Somebody else. Which one?
It's kind of on two different problems. For the first step, when
Which problem? Give me the
it's
name.
4.24 and 4.26.
All right, let's do 2-4 real quick. All right.
I'm just confused for the first part how you got VC.
All right. Well, give me 1 second, and I'll try to straighten it out. This is 2-4.
Yes.
All right. Everybody, take a look at it. All right, is that the right circuit, by the way?
Yes.
Okay. So, this is t equals 0. The switch is closed for all time. Y'all follow me? So if you have any concern about this, redraw it. So for t less than 0, it looks like this. Now remember, t less than 0 to the time began, nothing is changing with time. Therefore, C dV dt is 0. There's no current through the capacitor. It's an open circuit. You all hear me on this? The only thing we need is that voltage across the capacitor. So I'm going to make it just dangling leads. And this is going to be plus to minus Vc of t. And then you have 6K. Now remember, I care only about this voltage. This is Vc for t less than 0. Sir, do you see that? All right. How do you get that, class? Take a look for a second. Just think about it. I'm not going to call it. You're going to make a comment. Just show your hands. How many see these two are in parallel? Do you see that? So you could replace them by what? 6 and 12, 4, is that right? Okay, I'm going to replace it. I'll get rid of this, leave that there. Make this 4K. I'm going to make a comment here. How many, don't say how many know how to get that voltage? All right, a lot of you don't. How would you get it? Anyway, if you want to know. How many say this voltage division is probably the quickest? With me? So what would that voltage be right here? Guys, what would you do? Start with this voltage, right? That would be 12. You all see the voltage across the 4K is VC. How many see that? Can you all see it back there? I worry about my writing. 12 is the original voltage here, the source. It would be times 4 over 4 plus 2 or 6, right? So that's going to be 2/3 times 12 or 8 volts. Do you see that? Everybody see that? Okay. Now that's that for t less than 0. Now the switch is open. I'm going to just use that circuit for the sake of time. I'm going to go right here and do it. So when this circuit opens up, when that switch opens, now here's probably your question, so pay attention. Please, everybody listen. I just took the switch out because it's open, not connected. How many understand that? You guys got it? How many see this part of the circuit has no influence on that part? Just show of hands. The reason is they're electrically isolated. You have to have 2 contact points with any system to have electrical influence or current or voltage. This would have to be connected at 2 points so current could flow in and out. Do you all follow me? If it's only connected at 1 point, it's effectively disconnected. It's isolated. So in order to help you, I'm going to erase all this. Now, question. What is the voltage across the capacitor as t goes to infinity and why? Don't answer yet. I want to make sure everybody hears this. I don't like speaking loud. What is it? How many know it's 0? Why? No current, no voltage, no problem. 0. How many got that? I hope I'm answering your questions. Was that it?
Yeah, it's just for 4.26, it's a similar looking circuit, but you don't do voltage division DC. I think you do across the parallel resistors.
I
can't tell.
I can't either. I don't even know the problem. You got me on that one. Well, the switch opens up, it takes that voltage source out of the circuit. After that, you got 2K and 4K in series and parallel with 12K. Take a look.
So
remember, the only thing you want is the voltage across that capacitor. I don't care about that. All right, you need that value, right? Those resistors are in parallel across that capacitor if you combine the 2K and 4K, or 2K and 4K, yeah, right? You see it? Essentially, that's the only thing you have to see. All the others, because once you have the voltage across that capacitor, the current through the 2K, 4K is just that voltage by 6K. Got it? All right, just to finish this one up, we didn't do R Thevenin. What is R Thevenin? I really hate yelling. I hear this low mutter, and sometimes I think, you're not going to hear me. What is R Thevenin there? And just take one look. How many see it? Is it 6K? I don't know. It must be a trick question. No, it's not. Confident in yourself, all right? These are not tricky. The only thing you have to do is think and be reasonable about the way you approach this, and don't just say, oh, it must be a trick. It's not a trick. It's that obvious, please. I've heard some of the craziest thoughts, like, I knew it couldn't be that simple. It is that simple. Y'all got me? I'm not trying to scold you, but please. All right. Last thing. Give me 2 minutes and you'll get your quiz, but I want you to hear me. I didn't talk about inductors. I'm about to. Now. Uh-oh. That quiz may just take a turn for the worse in a heartbeat. I want to make sure I get your attention. Or I'll really get your attention. I always have a second quiz up my sleeve that can make life very hard. All right, ready? Here's an inductor symbol. How many have seen it before? The relationship between current and voltage in this, does anybody know it? Well, the voltage across that inductor as a function of time is L di dt. You'll notice the positive current is entering the positive terminal. Now, what that means is, when we go through, and I'm not going to do them now, the differential equations, just like we did before, they'll be the same form, but instead of voltage, it will be current that we find. You got that? That's the only point I'm making. I'm going to give you reading, and I'm going to give you a few simple problems. I'm going to pick it up Monday, but I want to introduce it today so that it won't be, out of the blue. I'll give you a few things. Please do them. If you don't understand them, we'll talk about it. All right, come on down. This is the new graduate.
A new one? Oh my god. This Quaker is going to be an abomination, to be honest. But